Now, for question 4, we are tackling this question of a rotation of a rod with a collar on it. So, this question says that there's a rotation of the rod OA about the point O. Okay, and this theta is not a constant, and the R is also not a constant, it's time dependent. So over here we write that theta is 2t squared and R is 60t squared minus 20t cubed. Alright, so we're trying to find out what's the velocity of this collar when time equals to 1 and the total acceleration when time equals to 1. So to do this question, let's write down the general velocity form, and that will be v equals to r dot er plus r theta dot e theta. To find r dot and theta dot, because these are the two unknowns that we do not have, we have r. We can solve it very easily by doing differentiation. So let's differentiate r with respect to time to find r dot, and we'll find this and evaluate this r dot at t equals to 1. I'll get 60 mm per second. Likewise, theta is 2t squared. So by evaluating theta at t equals to 1, I can find out it to be 2 radians, and I change it to degrees. Later you'll understand why I changed the units to degree. Then I'll differentiate 2t squared, which is theta, and I'll get 4t, and that will be theta dot. Again, I'll evaluate this at t equals to 1 second, and that will be 4 radians per second. So now I know that I have this r equation given to me, and I can very simply evaluate it at t equals 1 second to find out this to be 40 mm. By having all these unknowns that we just solved, which is r dot, r, and theta dot, we can now sub it into this equation and find out this. Velocity will be equals to 60 er plus 160 e theta. And just find the absolute value, that will be 170.88 mm per second. And I'll find the phi. Our arc tangent, which is just a tangent inverse 160 over 60, and this gives me 69.444 degrees. So what's phi? Phi is this. So I will always take the arc tangent of the e theta over the er to find the angle over here. Okay, but that's not the absolute angle, because this frame is not the absolute frame. Absolute frame is this whole thing taken from the x and y axis. These e theta and er are not x and y axis. Hence we need to consider this theta. That's why I converted it to be degree form. Okay, so very simply I just take phi plus theta, and that will give me the absolute position. So that's 184 degrees. So the velocity will be 170.88 with respect to 184.036 degrees from the positive x axis. So that's the answer for the velocity. For acceleration, it's relatively simple. I'll take the acceleration general formula, or basically the general form, and find out what I do not have. So I do not have r double dot and theta double dot. So very simply, I just differentiate r dot with respect to time, and I'll get 120 minus 120t. Evaluate this at t equals to 1 second, that gives me 0 mm per second squared. Theta dot, I'll just differentiate theta dot with respect to time to find theta double dot, and that gives me 4 radians per second squared. Once I have all my unknowns, I just sub everything into the general form, and I'll find this to be negative 640 er plus 640 e theta. I'll take the absolute value and find that out to be 905.097 mm per second squared. Again, I will do my arc tangent of my e theta with over my er, and I'll find it out to be 135 degrees. However, when you punch this into your calculator, you will get a negative 45 degrees. This is because your calculator is not able to tell whether this negative is in the denominator or the numerator. So to allow you to understand this properly, you should draw out the vector. So in this case, I know that er is a negative value. So this is positive er. When I go to negative er, it's around here. So it should end up somewhere in this part of the graph. And then e theta is positive, so it's over here. Hence I can expect that the vector is within this quadrant. Okay, so once I expect this to be in this quadrant, then I'll do the arc tangent. So when I find arc tangent, they'll give me negative 45 degrees, but that is trying to tell me that it's over here. Okay, so to get 135, just 180 degree minus 45 degree, and you get 35 degree. Again, you will add on to theta because you are trying to take the absolute frame, and that will be 249.592 degrees. And the answer will be 905.097, and that is 249.592 degrees from the positive x-axis. Now, the last part of the question, right, they're talking about the acceleration of the collar relative to the rod. So what does this mean? What does this mean? So take this blue stick over here to be the absolute frame. So you only focus on what is going on along this rod. So will this collar go along this rod? Will it move along this rod? According to our calculation, our r double dot is 0. Therefore, there is no acceleration relative to this rod. Hence, the answer is 0. So that's why it's 0 over here. They're just trying to ask for the acceleration of the collar relative to the rod. Since r double dot is 0, that means there is no acceleration relative to the rod. That's why part C is 0.